Good afternoon.
Good afternoon.
So you have a test on Monday?
Yeah, science.
Okay. I didn't get the complete chapter pics.
You want me to send it?
Yeah, just send me no.
Yeah, like in the group.
Uh, you can. Which number you're using?
My mom's phone number.
906.
Yeah, 96.
Okay, I'll just text you there. You just send me here. Okay.
Yeah.
So that which textbook it is? Oxford
Collins.
Collins, right? So I need to buy that. So till then, you can just send me the whatever subtopic has been completed. Till that, you can just send me.
And send.
Yeah, yeah, sure.
Like, I don't have your numbers.
No, I've just texted you hi
Okay.
on that number. Okay,
Oh, yeah,
906.
yeah. Okay.
Yeah. Popularity.
Like, do you want me to send the whole chapter or only the exercises?
For now, only till what the portion has been completed for you. Okay.
Yeah, like
Now,
chapter
once you are,
or the exercises?
what you want me to do today?
Uh, chemistry.
Chemical changes and that only. But what you want? Exercise or you want the concepts?
Like both of them, but most is
Mm-hmm.
like concepts.
Okay, then just send me like whatever is there for the test, right? So
Yeah,
that part,
yeah.
just send me.
Right. I sent.
Yeah, I'm checking. Now, which subtopic you want? From starting only you have no for the test.
Yeah, but most main thing is like chemical changes.
Okay, chemical changes.
Like it's the fifth one which I sent. Fifth page.
You know how to write the chemical formula, chemical symbol.
Yeah.
So that we can do only for exam purpose. Okay. How to write a chemical equation?
Yeah.
Balancing chemical equation.
Yeah.
Writing a chemical formula. So in the last class, we have seen now, okay, about what are pure substances, right? We have seen what is matter made up of, what are atoms, what are molecules, what are elements, what are compounds, okay, what are mixtures, types of mixtures also we have done. Now, what to do is chemical symbols for elements, then chemical equation for chemical reaction, okay. Then we have to do the chemical formula for molecules of elements or compound, that is representation. Then physical change, chemical change. In chemical change, they have told only rusting, browning of fruits and vegetable, reaction of baking soda and vinegar. And physical changes, crystallization. That's it. Only this much. Like these few concepts, right? As I don't have a textbook, so that is only a big problem for me. Okay, so I should get that one. You just tell me the concepts, okay? Whichever you want, then I shall explain it. That will be better. Okay. So you can just tell me whatever you want.
Yeah.
From exam point of view, like for exam, you have physical and chemical change, right?
Yeah.
Hmm.
So like we have and like from chemical changes we have change in color first one, then we have formation of gas, evaluation of absorption of heat, for formation of a precipitate,
Huh.
emission of light, and then we have rusting and prevention of rusting. Then we have browning of fruits and reaction between vinegar and baking soda. Then physical changes and crystallization.
Okay, okay, okay. So you have started it from where you said?
Um, chemical changes.
Chemical changes.
Uh,
Change in color, right? Okay.
yeah.
You have said half of pics. Pics are not clear. Okay.
Not bad.
Yeah, it's half of. We have sent it cropped.
Let me see.
So chemical changes, okay. So the changes in which two or more substances combine chemically to form new with different properties are called chemical changes. So if you have sent me that, just send me properly, those pics because I'm not able to see half of there. It is it is cropped. Just hold it from above. For time being, you can just send me two pics. Okay, later we can just go on. Hmm. So what is change in color? So what are chemical changes? It is said that when two or more substances combine chemically, okay, to form new substances with different properties. So this is called as what? It is called as chemical changes. So when two or more substances they combine chemically, okay. Suppose some solutions you are going to mix, okay. Now one solution if you mixed with another, so it will produce some other solution. So if suppose uh, I take HCl and NaOH. Okay, so what it will give you? It will give you NaCl. So this will be a salt. Okay, so there will be so this is a acid, this is a base, and this is a salt. Okay, and water is produced, right? So the properties of each chemical here is different. Right. So what it is said, so when two or more substances, when they add, okay, when they add chemically, okay, they form new substance, right? So is it same? No, the substance is different. So it is producing different substances, okay, and the property is also different. This is acid, this is a base, okay, and this is a salt. So the property of each here is different. So all are so it is showing what? It is showing a chemical changes. So these chemical changes are also called as the chemical reactions, okay? And these are irreversible. Means what? Once the acid and base reacts,
Yeah,
it
they
forms
won't
salt.
turn back into the
It
normal.
won't turn back. You won't get back the acid and base. Okay, so these are irreversible. You won't get them back. So they are said to be irreversible. as the original product. So you cannot get it as original products, cannot be obtained back. So your original products cannot be obtained back. Okay. For example, the raw fruits cannot be obtained back from the ripened fruit. So once the fruits are raw, okay, and slowly what happens, they undergo slow chemical changes and they get ripened. So once the fruit are ripened, they won't be converted back to the raw form. Okay. Wood cannot be obtained back from the ashes. So wood, okay, wood. So if you burn the wood, what will happen? The wood will be converted into ash. Okay, so this ashes again, so what is happening? You are converting it into ash. So this ash cannot be converted back to the wood. So this is also a chemical change. So it is irreversible. Irreversible meaning what? It cannot be converted back. Okay. So after burning of the wood, then chemical changes result in the formation of new substances with different property. As I discussed, so both the reactants were different and the product form will be different. So all are having different chemical properties. So their properties will be different from those of the reactants. Okay, so products property will be different and the reactants property will be different. For example, hydrogen. They have taken hydrogen plus oxygen. These both are gases that burn. Okay, so hydrogen and oxygens are both gases that burn. However, the two react chemically to form what? Water. Okay, so hydrogen and oxygen, these are what? These are gases, but they form what? And they will burn. Okay, they both are gases that burns. Okay, these both burns. Okay, but what will it will form? It will form water, which is a liquid, right? So the property is entirely different. So both are gases, and the product obtained will be a water, which is a liquid in state. And this liquid does not burn. So this liquid does not burn, right? So hydrogen and oxygen, they are gases and they burn, okay, but they form what? They form to give you water, okay, which does not burn. So these are the different chemical changes. You can see that the reactants properties are different and the products properties are different. Okay. So a few more properties of chemical changes are given below. So these are the properties. The first one is change in color. So first one is what? Change in color. So change in color, a change in color may indicate that a product has formed that is different from reactants. Okay, means what? Here you can see the change by looking at the color. So they have taken two test tubes. Okay, now what they have done? So a change in color may indicate that a product has formed that is different from the reactants. For example, when a nail, iron nail is immersed in blue color copper sulfate solution. So you take a test tube. In this, you take what? Copper sulfate solution. Okay, you take copper sulfate solution, which is blue in color. So copper sulfate solution is blue in color. Okay, so this copper sulfate solution you have taken in one beaker, and in this you add what you will add. You add a iron. Okay, iron. So iron nail should be immersed in this particular blue color copper sulfate solution. What will happen? The solution, it will turn green. So this solution, it turns green. So this solution, what happens? It turns into green. Okay. So this will turn into green. So why the solution is turning green? Because the iron, okay, the iron which is there, that is the iron nail. Okay, so this is reacting with the copper sulfate solution. Okay, so what is happening? The iron nail. So iron is nothing but Fe. Okay, so Fe is reacting with copper sulfate solution. So what is happening here? It is turning into green color. Then it is forming iron sulfate. So it is converting the copper. Okay, there will be replacement reaction. So the copper will be replaced by Fe because Fe, that is iron, is reacting with copper sulfate solution and it turns the blue color solution into green color solution. So this indicates the change in color. So change in color can be means what? It indicates, it shows that the changes, when you see that the color is changed, that means there is a chemical change which is happening. So this is one property. So whenever chemical changes or chemical reactions are what they are going, Okay, so if there is a change in color, so this also indicates that there is a chemical change. So as they have given the equation, as I have told, copper sulfate plus iron. Okay, what is happened? Copper sulfate is a solution, iron is the nail. So what is happening? It is forming iron sulfate plus copper. Iron sulfate, how it is forming iron sulfate? Yes, how it is forming iron sulfate? So
Because you
copper.
put the iron nail
Yes.
inside the copper.
So how the reaction will take place? Just see here, iron I will combine with sulfate like that. Okay, and this copper will be left alone here. So copper like this. So this is a replacement reaction. It is said to be replacement reaction. One metal which is more reactive will be replaced by the metal which is less reactive. So here iron is more reactive than copper. So iron is replacing your copper metal. Okay. So this is the first property, that is chemical, that is change in color. Okay. What is next after this?
After this, it's formation of gas.
Let me see if it is clear. Okay, formation of gas. This is also half. Can you send me that one page? So another property which indicates that there is a chemical change is the formation of gas.
I have sent.
Hmm?
Yes, sent it. Do you get it?
Yeah, I got it. Okay, so formation of gas is another property which indicates that the chemical change is occurring. So in some chemical changes, a gas is formed. So whenever some chemical reactions are occurring, what will happen? There will be formation of gas. Gas will be liberated. Okay, for example, hydrogen gas. So hydrogen gas, carbon dioxide gas. Okay, like that, the gases will be liberated. So whenever you can see that there is a gas, so you can say that if any reaction is occurring and there is a release of gas or liberation of gas, that means what? There is a indication of chemical change. So as a gas is formed as a product and is released as effervescence, so it is also termed as effervescence. Effervescence meaning what? uh when do you know this sealed bottles, okay, of
Yeah.
soda, maybe soda bottle. Okay,
Yeah.
Kinley bottle. So if you open the soda bottle, so you can see there will be a voice crackling sound, right? The gas will be so what is happening? When the bottles are filled, okay, when the bottles are filled, what they'll do, they will compress with carbon dioxide gas. Okay, they'll compress that with carbon dioxide gas. So when you release it, so you get that sounds.
Yeah.
You get that sound of effervescence. So that is nothing but effervescence. So what is happening there? There will be release of gas, which carbon dioxide gas. So effervescence. So the product obtained will be a gas. Okay. So product obtained will be a gas which is called as the effervescence. Fine. So common chemical reactions with effervescence usually release either carbon dioxide. So which are the common gases which are released? Common gases. Okay. Common gases which are released are carbon dioxide, then hydrogen gas and ammonia, NH3. Okay. So these are the common gases which are released. Okay. So that is carbon dioxide, hydrogen gas, and or ammonia. So these are the gases which are released when a chemical reaction is occurring. For example, when zinc granules means pieces of zinc. Okay, zinc is a metal. So zinc metal, when you are adding it with HCl, that is hydrochloric acid. Okay, hydrochloric acid is nothing but your HCl. So when zinc granule, that is pieces of zinc, is treated with your HCl, okay, so what it will form? It will form ZnCl2. It forms ZnCl2 plus hydrogen gas will be liberated. Okay, it forms ZnCl2. So this is a product and this is also a product, but this is a gas. So there will be with the liberation of gas. So when you can see that the gas is released, that means what? The reaction has been occurred. A chemical change has been occurred. So this is the example or the property which indicates that a chemical change is occurring. So zinc granules, when you treat it with HCl, okay, when you treat it with hydrochloric acid, it gives you ZnCl2 plus hydrogen gas will be liberated. Okay, so word reactions and balanced reactions for the reaction that takes place between zinc and zinc granules. Okay, so how it is given? Zn plus HCl. Okay, as I have written already, Zn plus 2HCl, ZnCl2 plus H2, because H2 gas will be liberated. So this arrow mark, okay, upwards, it indicates that the gas is liberated. Okay, the gas is liberation of gas. Okay, liberation of gas is indicated by this arrow. Okay, so Zn, see the number of atoms here in left hand side and right hand side. Zn is there, then H is there and Cl is there. Zn is there, H is there and Cl is there. Number of atom 1. HCl 2, Cl 2, Zn 1, hydrogen 2, Cl 2. So it is a balanced equation. Okay, it is a balanced equation. So this tells you that the reaction is being balanced. So this is when the zinc granules are treated with hydrochloric acid, you get ZnCl2 with the release or liberation of hydrogen gas. Next is evolution or absorption of light, absorption of heat. So the next property which indicates that there is a change or chemical change, that is evolution or absorption of heat, when the heat is absorbed. Okay, so a chemical change may cause the evolution or absorption of heat, thus changing the temperature of reaction mixture. Now suppose a reaction is occurring, okay, and you can see there is sudden rise in the reaction. So that also indicates that there is some chemical change. Okay, suppose firstly, okay, if the solution is cool, okay, now two reactants, suppose A and B, these two are cold. Okay, they are cold. You can say they are like normal temperature. They are at normal temperature. But after they react, okay, after they react and they form product C and D, okay, so this will be having some high temperature. It will show some temperature, high temperature. Okay, so this indicates that there is a chemical change. So whenever there is absorption of heat, or you can say evolution of heat, this also indicates that is when there is a change in temperature. Evolution is nothing but change in temperature. Okay, change in temperature is nothing but evolution. Okay, so for example, when carbon, so what will be the example? So if I take carbon, so when carbon reacts with oxygen, okay, when carbon reacts with oxygen, it gives you carbon dioxide. Carbon dioxide plus heat is evolved, plus heat is evolved. So I'll write, so this is a word equation. Okay, this is a word equation. I'm writing in terms of word. Now I'll write the in form of balanced equation. Okay, chemical equation, I'll write it. So carbon is C, oxygen is O2, and it gives you CO2 plus heat. Okay, so like this is the reaction. Is it balanced reaction? Just check, is it balanced? Is it a balanced reaction? You can see carbon, number of carbon atoms are on the left hand side. You're you're on mute.
Yeah, they are equal because
Yeah.
because
Okay.
in the LHS the carbon is also 1 and oxygen is 2. Even in the RHS,
They
uh,
are
carbon is 1 and oxygen is 2.
yes. Okay. So it is balanced. So it is a balanced reaction. Okay. So whenever there is change in temperature, okay. So this also indicates that it is undergoing a chemical change. So one more reaction. Carbon reacts with carbon. Okay. Reacts with sulfur. When it reacts with sulfur, okay. With sulfur absorbing heat and forms carbon disulfide. Okay. It forms carbon disulfide.
Right.
So carbon, when it reacts with sulfur, it gives you carbon S2. Okay. So it forms, so this will be 2S. So suppose now you don't know. So how I'll do now? See here, carbon and I have taken sulfur and carbon di. Di means the sulfide will be 2. So it will be CS2. Now I will just see whether it is balanced or no. Carbon, sulfur, carbon, sulfur. Carbon is 1, carbon is 1, sulfur is 1, this is 2. So what I would do, I'll write here 2. Okay, so now it will be balanced. So
Yeah.
now this will be balanced. Okay, so like this. So if you don't know, first you write carbon plus sulfur, then carbon disulfide means S2. So left hand side will be equal to right hand side. So just see the number of atoms and then you can balance the reaction. So like this. So whenever there is change in temperature or evolution of evolution or absorption of heat, okay, that means what? So here evolution means what? So just a second. So carbon plus sulfur plus heat. It takes up the heat. It requires heat to form carbon disulfide. It requires heat. It requires heat. Okay. So here what is happening? It is absorbing. It is absorbing heat. It is absorbing means what? It is taking heat. When the reaction is occurring, it is taking heat. Okay. And the first reaction, carbon plus oxygen giving you carbon dioxide plus heat. So this is what is happening. Heat is evolved. Okay. Or heat is released, you can say. Heat is released here. I'll just use this
But
term.
you won't include that in balancing, right? You
No,
won't
no, no.
include heat.
No. We don't include that in balancing. Okay, just you can feel it, you can just feel it. Okay, by the change in temperature, by changing temperature you can just feel it. So here in this reaction, what is happening when carbon is reacting with sulfur? It requires heat. The heat is absorbed, okay, to form carbon disulfide. But when carbon is reacting with O2, that is oxygen, what is happening here? It is forming carbon dioxide plus heat is evolved. Okay, heat is evolved or heat is released. Okay, so this is the main difference. So absorbing is different and evolved is different. So both the terms are different and means what is happening here? There will be change in temperature. So this will be change in temperature. So I'll write the chemical giving you CS2. Okay, this will be 2S. So this is the third property. So what all we have seen? Change in color. Then we have seen
Formation of gas.
formation of gas. Then we have seen evolution,
Absorption.
absorption of heat. Okay, so next we are going to see is formation of precipitate.
So, like, what do you mean by a precipitate?
Precipitate means, you know how curd looks?
Yeah.
Okay, so I'll give you example. So same like curd, okay? So like white, it will be in the form of white,
Yeah.
yellow, orange. So these are the colors of that precipitate, means how the curd will be white. Curdy, okay, in the form of curdy. This, so same it will be white in the form of white. Okay, yellow curd, yellow color. Okay, just give a yellow color. to the curd, how it looks.
Yeah.
Give slight yellow orange color to the curd. Okay, so like these are precipitate. What is precipitate? It is a insoluble salt. Insoluble salt means what? Just a second. So it is a insoluble salt. They have given, see, a precipitate is a insoluble compound. Okay, precipitate is an insoluble compound which is found in reacting or reaction involving the solution. Means what? There will be two solutions. Okay, so they have given an example that I'll explain first, then I'll go through your doubts. Okay, so here, so it is a insoluble. What is a precipitate? So precipitate can be also written as PPT. Okay, it is also called as PPT. So precipitate is a insoluble salt. Insoluble salt. It is a insoluble salt. Okay, which is formed in reacting involving solution. So for example, when colorless solution of lead nitrate. So lead nitrate is a solution. Okay, it is a chemical which is colorless. It don't have a color. Colorless means what? It is like water. Like water. Okay, there won't be any color for this. So it will be like water.
Okay.
Then, so when colorless solutions of lead nitrate, potassium iodide are mixed. So both the solutions, potassium iodide, potassium
Iodide.
that is Ki. Lead nitrate is PbNO3 twice. Okay, PbNO3 twice. So when this colorless solution of lead nitrate reacts with what? Potassium iodide. Okay, what it forms? It forms a colored solution. Okay,
Yeah.
so lead nitrate and potassium iodide, they react with
Lead
each
iodide plus lead. Sorry,
lead
plus
nitrate
potassium
iodide. Okay, when it reacts with each other, so it forms a yellow color precipitate. Yellow color precipitate of lead iode. That is lead iodide. Okay, how it will be? Just see, lead will combine with this and potassium nitrate. Now you know why it forms like this only. So Pb will be +2.
Okay.
Nitrate NO3.
Yeah.
Okay, NO3, each NO3 is -1. Each NO3 is the charge is -1. So there are, now you know that this is +2, this is -2. For a compound, okay, it should be it should have a 0 charge, complete charge, right? So now this is +2. So this I should make what? -2. +2 and -2 will get cancelled and it will become 0, or the overall charge will be 0. So what I should do to get this -2, I will take 2 atoms of nitrate. Right? Each atom is -1. 2 atoms will be -2. So the overall charge will be -2. So -2, this will be +2. So now here, just see. So NO3 -1. Okay, or -2 you can take because these are 2 atoms. Okay. Means what? It has a minus charge on that. Just don't get confused. So it will be NO3 twice. Okay. And it has a minus charge.
Minus
2.
Yeah.
Because there are 2 atoms. Each, see, NO3, it has -1 charge. There are 2 atoms, it will be -2. Because this is +2. So +2 -2, the overall charge on the molecule should be 0. Now Ki, potassium is +1. Iodide is -1. +1 -1 get cancels, it will be Ki.
Yeah.
Right. Now, how it is getting replaced, how the reaction is getting replaced, just see here. So
is it going to be like lead iodide and potassium nitrate?
yes, potassium nitrate and lead iodide, that only. So what will happen now? This is plus charge, this is minus charge. So this plus charge will be getting exchanged with the minus. Means what? Lead and reacts with iodide, and potassium will react with this negative part. Okay, so potassium is plus, it will get reacted with nitrate. So what products it will form? It will form what?
It will form lead. I got it. Yes, potassium.
Okay, it forms lead
Iodide,
iodide plus potassium
potassium nitrate.
nitrate, like this.
Okay.
K2 it will be.
But nitrate is like NO3 twice or only NO3?
Now this will be, yes. Now this will be potassium, right? So
Yeah.
potassium is plus 1. Now here potassium is plus 1, NO3 is minus 1. So it will be KNO3.
Okay.
So this will be KNO3. So the reaction, the products formed will be potassium iodide and KNO3. Okay, so these are the
Yeah.
products which are formed. So this tells you the precipitate. Now this will be both are colorless. But when this reacts to form your PBI, that is potassium iodide, it gives you what? Now this PB, again here, PB is what? PB is plus 2.
Yeah.
Iodide is what? Minus 1. So what I should do?
I
What I
think,
should PB is plus 2.
yeah.
Iodide is minus 1. How I'll, what is the formula?
You're gonna plus 2 minus 2.
But how? If I take this 2 iodide, right?
Yeah, yeah.
So it will be PbI2. So this will be PbI2.
Okay.
Okay, so this will be PbI2. So the reaction, what we get, what is what?
It is
PB,
I2 plus 2 KNO3.
yeah.
It's like it's gonna be 2 KNO3, right? In the potassium nitrate. It's supposed to like 2 KNO3, like in potassium nitrate.
KNO3.
Yeah.
Potassium is plus 1. This is NO3 is minus 1. So this is 0. Fine. The molecule is formed. PB is
No,
plus 2.
no, like in KNO3, it's supposed to like become 2, right?
What? But just a second.
Like
I'll just clear this one.
2
It's here.
KNO3.
Potassium, sorry, lead nitrate plus Ki gives you. So what will happen now? This PB will be
Yeah,
PB.
yeah.
Okay. PB is plus 2. Now iodine is minus 1. So it becomes PbI2
Plus 2
plus,
KNO3 because there's 2 down.
where?
It's gonna be 2 KNO3.
Okay. Fine. That will see balancing. Just a second. Wait.
Yeah.
Now K. Okay. Then NO3. Why? Because potassium is plus 1. This is minus 1. So this will be 0.
0.
Okay. Now we'll see the balancing. Now we'll go for balancing. So LHS and RHS. LHS PB, then NO3, then K, and then I. PB, I. Sorry, I'll just go with that sequence only. It will be good for us. Then NO3 minus. Okay. This is then potassium. This is iodine. Now
There it's 1.
PB is 1. PB is 1. NO3 is 2.
2.
Your NO3 is 1.
1.
K is 1. Iodine is 1. K is 1. Iodine is 2. So what I'll do, I
You
can.
are supposed to put 2 to the KNO3. Over here, you're supposed to put 2.
Put 2
Yeah.
here.
Yeah. In the LHS. Then over here, in the RHS, put 2 again.
2 add Ki.
Yeah, you're supposed to put
here also 2.
Yeah.
So this now you check 2 Ki,
2 and
2 iodine,
over here 2.
2 K and 2 NO3. Just check. Yes. Now it is balanced.
Yeah.
So this is the balanced chemical equation. So now what do you mean by precipitate? So it will be like in the form of curdy precipitate. Curdy. Okay, in the form of curd. It will be like curd. so it will be insoluble. So when these two reactions, okay, which are you can say colorless solutions, okay, it reacts and it forms an insoluble salt. So these salt, it won't be soluble in water. So it is called as a precipitate. So precipitate is nothing but insoluble salt, also called as PPT. It is also called as PPT. So this is about the precipitate. So this is another property for explaining your chemical change. Next is emission of light, sound or smell. Okay, emission of light, sound or smell. So here, some reactions may involve the emission. Okay, burning is a chemical change that usually involve the emission of heat, and magnesium ribbon burns in oxygen with dazzling white light. When fire catches lit, they explode, producing loud sounds and smoke.
Yeah.
So this is also another chemical reaction, okay, wherein the chemical reaction is determined by sounds, okay. Means
Like
what
this
the
one
popping sound.
I've understood, like I don't need a lot of explanation for this.
Okay, fine. Then next where we go?
Rusting. The next
Okay, rusting. So rusting is what? Okay, rusting. What do you mean by rusting? Now
Yeah.
you know for gates. Okay,
Yeah.
the gate in front of your house. Now that will be what like
Yeah.
we usually paint them. Okay, we usually paint them. Why we paint them?
To
Because it
prevent
is very,
the rusting.
yes,
If like when iron includes with water and oxygen, they
yes.
form rust.
Yes. So when iron, okay, so iron, it will be first like steel only. It looks like what you can say, a brown color, not
Yeah.
brown color,
It's
slightly you can
metallic
say,
color.
yeah, metallic color. Okay, it will be like metallic. But
Yeah.
if you don't paint it, if you just keep it open to air and moisture, what will happen? It starts getting rusting. Okay,
Yeah.
it catches
Yeah.
rusting. Rusting
Yeah.
means what? It turns into brown color. Okay, down brown, reddish brown. It will be reddish brown. So this is nothing but rusting. Rusting is what you are completing, exposing it to what it is for moisture and oxygen, okay, or air which is present. So uh, when you are giving it or you are making it to react with air and oxygen, it is undergoing rusting. So for rusting, what you have to do, what is the how you have to prevent it from rusting?
You can paint, you can oil or grease it, or you can
Huh.
tin it.
Yes.
Galvanization and tin
So
it.
these are some of the, so these are the reaction. Okay. So here they have given C reaction also.
Yeah, like you can put oil and dry air will
See,
also.
okay, when you react with water and oxygen present in the atmosphere, it forms ferric oxide. It forms
Yeah.
what? It forms ferric oxide. So when Fe
Fe2O3.
reacts with H2O and oxygen, so rusting equation is important. Okay, if they ask you write the rusting equation, you need to know this. So
Yeah,
when
yeah.
okay, so it will be two. So the balance equation is 2Fe plus H2O plus O2 giving you Fe2O3 dot X H2O. This is hydrated water. Hydrated water means what? Water molecule is associated with that. Okay, water
But over
molecule.
here, they've given two kinds. Like over here, in first equation, it's like a word equation. Over there,
Huh.
iron plus water plus oxygen, iron oxide. But
You
over here in the chemical equation, Fe plus H2, Fe plus H2O plus O2 forms Fe2O3 point XH2O.
can
That
you
is
measure
negative
water?
ferric oxide.
Can you measure water?
What?
Can you measure water?
No.
So it is given as X water. Okay. You cannot tell no how much water is reacted.
No, like in the first one, they've only given ferric oxide, and the
Yes,
second one, they've given hydrate.
hydrated water, because they have it is associated with water molecule only, but only thing what, how much moles of water is associated, we don't know. Okay, because in atmosphere, okay, what is happening, iron will be reacting with water as well as the oxygen which is present in the air. Okay, now water, it is reacting, so moisture, okay, in the form of moisture maybe. So it is called as, it is forming what, it will be hydrated only, so it is called as hydrated iron oxide, ferric oxide,
Okay.
because moisture is present, because in air, water and what is that, oxygen will be present, so that is reacting, so this Fe2O3 will be called as hydrated ferric oxide because it
Ferric.
will be associated with water molecules. Okay,
Okay. Oh, yeah, okay.
so the
So
rusting
there, even water is included. That's why they wrote
called
ferric
as
oxide.
hydrated. Hmm.
Yeah.
Chemical name of rust is iron oxide. Okay, remember that iron oxide. It is said as iron oxide. So when it is formed when iron is exposed to moisture, that is water vapor. You know that water vapor is present in the atmosphere, and oxygen that is in the air. So therefore, rusting is a chemical change. Okay, in which iron reacts with water and oxygen to form iron oxide, or it is also called as rust. Okay, so this is the reaction which is given. So rusting, okay, rusting in coastal areas, so where the weather is more humid, so
Yeah.
rusting is cause of lot of damages to bridges, ships, buildings and machines. Okay, because of
Yeah.
rusting, it causes more of damages. Okay, rusting can be prevented how, by not
Painting.
allowing to come in contact with air and oxygen. Okay, so some methods which can be used is by painting. So paint event or prevent surfaces of
Yeah.
iron object from coming in contact with air and moisture, thereby preventing rusting. Then next is oiling and greasing. So if you oil it regularly and grease it, okay, it forms a protective coating on the surface
Yeah.
of the iron object and prevents it contacts with air or
Yeah.
what,
What?
moisture.
Yeah.
Okay, then you know what is browning of fruit. So the, if you for app suppose apple, okay, if you cut the apple, okay, into 4 pieces, and if you keep it for only half an hour also, okay, can you see that there it turns into brown color? Yeah, so this is so even
Yes.
potatoes. Okay, so soon after, if you cut the potatoes, okay,
But
you
is
have
it harmful for us? No, right?
no, it is not harmful, but there will be some chemical change which is occurring. Okay, so fruits also. So the cut sizes of vegetables and fruits such as apple, pear, brinjals, or potatoes turn brown when left exposed to air. So this is called as browning. So browning, it is also a chemical change in which some compounds in certain fruits and vegetables react with oxygen in the air to form a brown colored substance which is called as melanin. Okay, so this
Mm.
substance which is turning which is like the brown color substance, okay, after reacting it with the oxygen, it is turning a brown color substance, and this is called as melanin. Okay,
Mm.
so browning can be prevented in either by storing the fruit and vegetable slices under water, or by rubbing the cut surfaces with lime juice. So this is the prevention what you can do. So this is nothing but browning. So which is responsible? That is melanin. So when the so in certain compounds it has something. Okay, that is certain fruits and vegetables. What they do, they react with the oxygen, and it forms a brown colored substance. So what is that brown color substance? It is called as melanin. Okay, it is called as melanin.
Yeah.
Okay. Anything else?
No. That's it. I think like we have more, but I don't have a lot of doubt in those. So,
Okay, fine. So from like from the next class, we'll start from the starting. Okay, whatever is there.
yeah.
Hmm? Fine then. Okay. All the best for your exam.
Yeah.
Mhm. Okay. So we'll meet in the next week then. Okay.
Yeah.
Okay. Fine. You have my number. If you have any doubts, you can ask me anytime.
Yeah.
Okay then. Chalo. Bye bye.
Bye.